You are not audible.
Okay, just a second. I'm just enabling the live streaming. Just a second.
Hello.
Yes, sir. Sir, I think we should start, sir. Uh, Tariq, sir, shall we start? Oh. Kindly unmute yourself. Yes, sir.
Please carry on. Let's start.
Over to you, Bilal, sir. Bilal, sir, are you there?
You are not audible.
Yes, now it's fine. It's fine now.
Yes.
Sir, you can start.
Okay. Give me a second. So can you see my screen?
Just a second, sir. First,
Just
Bilal, sir, will start, and then
Okay.
you will.
Sure.
Okay.
Honorable Principal Secretary to Government Higher Education Department, Shri Alok Kumar, IAS. Special Secretary to Higher Education, Dr. Ravi Shankar Sharma. Director Colleges, Professor Yasmin Ashai. Nodal Principal, Professor Ajaz Bashir. Our worthy Principal, Professor Mohammad Farooq Rathar. Our senior colleague, Professor Tariq Ahmad Chalku. Other distinguished faculty members, students, and other members, Assalamu alaikum and good afternoon.
Yeah.
Dear participants, I, Dr. Bilal Makbul, Assistant Professor Computer Applications, on behalf of the college and IQC, welcomes you to the fourth session of Convergence 360, exploring advances in sciences, humanities, and technologies under the aegis of Viksit Bharat 2047. The webinar series is initiated by IKC of GDC Baramla. The main aim of series was to provide the platform to speakers, faculty, and researchers for exchanging their innovative ideas and research findings. Dear participants, our college has taken a lead role in implementing government policies which imparts skill and knowledge to deliver in the area for fulfilling the dreams of our Prime Minister Shri Narendra Modi ji. Dear participants, let us join hands together to work for Viksit Bharat 2047. I would like to request our senior colleague, Professor Tariq Ahmad Chalaku, Professor of Physics and Dean Skill Development Cell of GDC Baramla, to formally welcome the guest as well as share his valuable sights with the participants. Over to you, sir.
Thank you very much. I hope I am audible.
Yes, sir.
First of all, my all gratitude to Dr. Harun Rashid Loan for joining us and being the guest speaker of the day. Equally thankful to Dr. Akib and Dr. Bilal for conducting this session. We have been doing this for information of Dr. Harun and others who are joining us for the first time. That a sequel of the lectures has been going on since last couple of days for Convergence 360, which is our title, under the aegis of Viksit Bharat at 2047. And I'm myself excited to have this session today because something which was once upon time a thing of luxury, that is an electric or a normal run vehicle, has become now an essential good, and it is an essential thing in our homes. And you can see that sometimes a couple of homes will have more than 2 to 3 vehicles for the members of the family. And definitely the kind of maneuvering of these vehicles has changed from time to time. Being a student of physics myself, I understand that two very important crises which this current century is going to face is the environmental pollution, environmental degradation, and energy crisis. Both these things, they place an electric vehicle at the right position because we are trying to shift over from the carbon to the hydrogen sources of energy, and a fuel cell necessitates that we shift over from burning petroleum and diesel, which is otherwise depleting on the planet, that we shift over to the electric vehicle. That makes an electric vehicle a thing of future, which has come to stay, and the technology is getting updated so much so that we have now the provision of Internet of Things being utilized and leveraged for the future course of action. The expert of the day will amply throw light on all the kind of possibilities which Internet of Things can do. But just to my mind, what occurs is that Internet of Things could be a great leveraging technology in integrating it with an electric vehicle. We can first talk about the safety and security of the vehicle. We can talk about the managing the kind of fault finding in a vehicle, or integrating this vehicle to the dealer or to a service station who can sense it from the sensors of the vehicle, that where the fault is going to develop over a period of time, and inform the owner or the driver that how it is going to help him. We could also think of energy management through these vehicles, because this vehicle becomes a storehouse of energy. Like we have the grid interactive roof solar tops now. We could utilize this vehicle as a source of energy in the times of crisis or the times of need. We could also be sure about the tracking of these vehicles, as we are doing it through GPS, but IoT will be another kind of level which can help us on this. And kind of questions which sometimes occur to me, because I'm not an expert on this subject, which Dr. Harun will definitely inform us about, that could it be that we can go for a hands-free operation of a vehicle by making it voice controlled, the way we have the mobile devices now, or we have many of the things which we are managing through the voice commands. Also, that how it could help us in the fleet management, or how it could help us in managing the energy and environment around us. All those things are going to be very exciting and very incubative, and I'm very sure that the students and teachers who are tied to the platform today, they will be adding all the kind of innovative ideas, and the takeaways from this session are going to be great. I welcome once again Dr. Harun Rashid Loon, that he has been engaging with us for this session, and I'm very sure that it is going to be a highly beneficial session for all of us. Thank you from my side. Over to you.
Bilal sir, kindly unmute yourself.
Yes. Before proceeding formally, I will briefly introduce today's speaker. Today we have with us Dr. Harun Rashid, Assistant Professor, Department of Computer Science, Indian Institute of Science, Education and Research, Bhopal. Dr. Harun did his PhD from IIIT and postdoc from University of Virginia. Dr. Harun is an applied researcher working at the intersection of Internet of Things, machine learning, and data science. His research involves deploying sensors, collecting and analyzing data, and building models using machine learning and data science approach. The overall theme of his research is urban computing, focusing on smart healthcare, energy sustainability, smart buildings, and smart transportation. His area of research interest is Internet of Things, machine learning, data science, smart healthcare, and energy sustainability. Dr. Harun has many publications in renowned journals and other book publications. He is currently working as an assistant professor in ISER Bhopal. I will not take much time. I will directly request Dr. Harun to take over.
Thank you. Thank you very much for this kind introduction. Let me quickly share my screen and see whether we can proceed. So can you see my screen?
Yes, yes, Harun sir.
Okay. Okay. Good afternoon, everyone. Hope you can hear me very clearly. Today, I'll go through this topic, and the topic is as the title says, leveraging Internet of Things for controlling and monitoring electrical vehicles. So at least I can see three buzzwords in the title, and I would like to justify them through the talk. So the first one is IoT. What is this Internet of Things? And the second thing I see this electrical vehicles, which we are very clear what this electrical vehicle is. And the third is controlling and monitoring. So basically what I just want to use this IoT technology to control and monitor my electric vehicles. Now, as Chalku sir he raised many interesting insights. I would not be able to answer all of those questions, but I would take a simple very important aspect of these electrical vehicles. I'll see how we can use IoT to manage that aspect. And I'm very sure that I'll give one hands-on example. And if you can correlate that example in bits and pieces, I'm very sure that you can use the same IoT technology for monitoring and controlling other aspects of the electrical vehicles. So uh, now the first question which comes to our mind, why vehicles? Why electrical vehicles? So we have been using these vehicles from multiple decades. What is special about these electrical vehicles? Or in simpler terms, why should we spend 1 hour of our time on these electrical vehicles? Without any further delay, if we see the main thing which kind of evolved or which got integrated in these electric vehicles is the batteries. Now, the batteries are there now. What's the trouble? We can the batteries we have been using from multiple years. This is not the first time, but then what is special about these batteries which are being used in the electrical vehicles? Now, we'll first try to understand where the challenge comes up. Then we'll see that how we can use IoT to handle that challenge. Okay. If we see these in electrical vehicle batteries, we have basically, instead of using this petroleum or diesel, we are using lithium ion batteries. Sorry. So these batteries are driven are they use these battery energy to to drive. And what is special of these lithium ion batteries in respect are with respect to other batteries, because we have a range of batteries available. And it turns out that at least we have three things. One, these are the high energy density batteries. They have low self-discharge rate, and then they have low maintenance. And if we see, if we try to investigate, it seems that it's a kind of win-win situation, because we can store more energy within a particular battery with a size of particular battery. Then discharge rate is very low. And being in Kashmir, we know that how good we feel when the discharge rate our mobile phone is very slow. And then there's a low maintenance. So now, giving all these things, it's a win-win situation. Then still, why don't we go to these electrical vehicles? It turns out that there is a catch, and the catch is the increased energy density of these batteries requires continuous monitoring. So this is a bigger troublemaker. And why this is trouble, we'll see it. So if we quickly see in our electrical vehicles, we usually monitor these vehicles once they start once our vehicle stops running, or we get some beep beep sound on our dashboard, or our these customer care people call us, irritate us, saying that, hey, your maintenance is due, you come and we'll service your car. But that usually happens maybe twice a year, once a year, or 3 times a year at maximum. But and one thing is clear, that we don't need continuous monitoring of our petroleum cars or diesel cars. But with these battery cars, they need continuous monitoring. And by continuous monitoring, we mean that it's not that you will say that after 10 minutes, I'll see what is the state of my battery. By continuous monitoring, we mean that we need to monitor our battery in the real time. Every second, what's going with our battery, we have to monitor it. Now, being humans, being lazy, we cannot do continuous monitoring, and it's kind of a very kind of a difficult or laborious job because it's not just one electrical vehicle. A car manufacturer, you take Tata or you take Suzuki, they take kind of produce lakhs of cars. How they can monitor these lakhs of cars or the batteries of these lakhs of cars? And here we need some kind of smart solution. And it turns out that IoT is there. That's the Internet of the Things. And with the time, I'll kind of unreveal what is this Internet of Things and how it will help us. So, but still, we are still building the basics. So when I say the monitoring of the battery, what do we need to monitor? So we are very aware of these things like the parameters of the battery. We have the current, something called voltage, temperature. At least all of these three parameters we have kind of studied in physics, or it was ninth physics or class 12 physics. So it turns out that these are three most crucial factors, or three most crucial parameters which we need to monitor over the time. Now, the thing is how we can monitor it. Is it like you put a temperature sensor, see a reading, and then you are done? Or there is kind of some other way. So we'll still go with the basics, and over the time we'll build the challenge. So it turns out that the batteries in these electrical vehicles are in different modules. So let me quickly take you through these modules. So this is something which we need to understand. So this is a platform of a EV vehicle, and where we see in the floor or kind of in the front side, we see these different boxes. So these boxes I called modules. So at least I can count this is one module, second module, third module, and maybe the fourth module. So now we will be over the time we'll see that how do we kind of connect these modules and how do we monitor these modules. So going back. And it turns out that these different modules, they are connected by a system, battery management system. And if we have to go with the analogy or with an example, you just take an example of your home where you have 5 bedrooms. And each of these rooms are connected with a single meter, which is kind of installed at your building mains or home mains. And then each of these rooms are connected to this central meter. That's the meter at your building mains. So what basically that meter does, it measures the energy consumption of each of your rooms. Similarly here, can we have this battery management system which can monitor the energy consumption or the parameters of these different modules? And quickly again to see what I'm trying to say. So I have these modules, 4 modules. If you see some wire is going here, let's suppose that this is electrical wire and this wire connects all these modules. And why do we need this? Why do we need to connect to these modules? Because in the real time, we want to see what's the total available energy of my car, or what's the discharge rate, and whether the batteries are synced with each other. So we need to have a mechanism through which they can kind of are connected with one another. So it turns out that in the traditional system, they were connected with a wire. So the physical wire which we usually get from this shop. So these wires we use to connect these different modules. And once they are connected over the wire, then we use different protocols. And what's a protocol? Like for example, here it's mentioned I2C, SPI, CAN. A basic definition of the protocol is the set of the rules. So when the different modules are connected over the wire, there should be some rules which they will obey or they will use to kind of connect or communicate with one another. So these are some wired protocols which are being used to connect different modules. So here, until this point, we don't have any problems. So it seems that even we have batteries, we can connect them over a wired connection, and we can see in the real time what is the charge, what is the discharge rate. So this is good. Let's move on. This I'm taking just one module. If you see here, it says battery pack, and on the battery pack, I see that I'm measuring current, voltage, and temperature. Then I see something here, some board. Let's go with this definition, this naive definition that we have some board. It's kind of a board which the kind of motherboard or the kind of motherboard we have in our mobile phones or in our laptop. So some kind of board is there, and it has some chips on it, and then it has some kind of indicator where basically it shows on the display what is the state of the charge, how much battery is remaining, what's the health of the battery, is your battery good, or it's kind of going to kind of its health is kind of degrading over the time, or what is the heat of what's the total heat of this battery, and can we optimize. So several parameters which we can monitor using this chip. And just hold on, I'll just explain what is this chip. So it turns out that somehow our batteries, in the real time from the batteries, we can compute several parameters, and then we can communicate. Here, communication, we can assume any kind of GPS connection or maybe the Wi-Fi, Bluetooth connection, and through which you can transfer the data or the state of the battery. But still, it's good. We don't have any problem as of now. It turns out that we have batteries, we can attach this circuit, and this shows us in the display what is the state of this module. Now, then where is the challenge? And this basically here I have this chip or which I say this board. If I try to zoom in, I see this is the size of the board. And what it says that it has several components. Let's not go into the details, but the thing which I want to highlight is on this board, I have something called as microcontroller. I have some resistors, I have some sensors, I have some some output cables or some output connections. So several things embedded on a board. And if you see how big is this board, you can just assume it's the size of the coin. So whatever size 10 rupee coin you have, you can just assume maybe one and a half of that coin. That's the size of this board. And it turns out that okay, so this is the board which is being used here, and we'll see over the time these boards are readily available in the market. It's just we have to figure it out which board we need to purchase, and then we can have this in our system. Now, this all was good, but now my problem is how to monitor N battery packs in real time. So the solution which we just started with a wired connection that works fantastic for a kind of one module. But what if I have N modules? How can I monitor them in the real time? Now, the problem with this wired system is it is slow. The rate at which you want to monitor the state of the battery with respect to that state, these wired connections are slow. Now, the research question or the question to us is, can we do something here? Can we, in naive words, can we remove this wire? So the question is, if we remove the wire, how we can monitor the state of the battery? So the specific question to you is wireless data transmission possible between the modules? Because at the end, we want to monitor n number of modules at the same time. And if the wireless connection does the job, and we know that the wireless has less delay as compared to the wired connection, here I just want to specify this thing. Don't generalize the wireless connection with the Bluetooth connection where the distance between two modules is kind of 1 meter or more than 1 meter. You just kind of concentrate here. It's we want to have the communication between different modules which are within the car, maybe within a distance of 1 feet or few feet. So can we do the wireless data transmission here? And it turns yes, we can do. And the way the wireless communication standards which existing are there, we'll see that can we use some of them, or we need to come up with some other standards. So it's just for your kind of information. We have different wireless standards. Like I have here this 802.11 ABG. So what is this? Basically, it's a Wi-Fi. You just take its kind of the standard name for the Wi-Fi which we use days, and then ABG are kind of, you say that it was I'm just giving you an example. We started with the 2G, then it was 2.5G, it was 3G, then 4G. And if we see what's the difference between different Gs, it's basically some kind of improvements with terms of the bandwidth or some storage. So those things happen. So similarly in the Wi-Fi, we had different standards, but at the end it's Wi-Fi. And then we have the Bluetooth, which you often use for transmitting the files. And then we have the GSM, which basically your SIM card uses to kind of connect with your mobile, this cell tower. So these are the existing wireless communication standards. Now the question here is, can we use these existing wireless standards and kind of get the communication done on this within the basically between the different modules? So it turns out that they are not kind of the favorable communication standards for the kind of thing which we want to do. We want to have communication between modules which are very nearby, and somehow we want to save the energy. We don't want to spend energy on the transmission, and we don't, maybe we want to transmit small packets. In that case, it turns out that these are not the relevant ones because they consume more power and they need lots of clock cycles. Or if we want to make it simplify, basically they need more memory, more RAM of your system to kind of get the communication done. Because when these standards are running in your system, they consume some real time this RAM of your system. But if you see these small, tiny nodes, small these microcontrollers, they don't have that much of storage. They don't have that much of the battery. So it turns out that we need to come up with some new wireless standard. And the answer is this 802.15.4 and then Zigbee. I totally get it that it may be difficult for you to kind of be okay with this terminology, but I would just request you to just listen to my story. And at the end, I will let you know that which are the things you should remember and which are the things you don't need to remember. As of now, you just keep in mind that Wi-Fi, Bluetooth, and GSM is not kind of going to work in these kind of IoT things, which while we want to have communication between these nearby devices, in that case, we have some other protocols, and I would just request you to kind of just remember Zigbee. Zigbee will make our life easy. So before kind of diving into the Zigbee, why we need Zigbee, I'll just give another aspect of from just the computer science perspective or from the communication perspective. Or I just assume all of you use the computer, so it's worth to kind of understand here what happens at the back end. So when you open the Gmail or when you open the internet browser, then you type something and you get something back, and then you say that it's very straightforward. Where is the science? Where is the computer science? But it turns out that it's very difficult. It's not that easy. So the kind of workhorse, the protocol which is being used in entire thing, we call this as an ISO model in the computer science. And I'll quickly go to kind of take you through this so that you get an intuition of what we are doing. So you just assume here that this application layer is the application which you are working in. For example, it can be an email application or it can be browser. Then it says underneath it is a transport layer. Then under it, there is a network layer. Then there is a logical link layer, medium access control, and the physical layer. Now, it turns out that when you are kind of composing your email, the kind of message you write, it gets divided into different packets, so data packets. Then that data packet, each of those packets, they go to the transport layer. Transport layer adds some information saying that, hey, this is the port number which while you have to arrive, or the port number from where you will leave my machine. Then it goes to the network layer. Network layer adds some more information saying that, hey, you now know this, you need to kind of leave or enter through this port, but you need to have an IP address. So IP address of the machine where you will be going. So this layer attaches the IP address. Then it goes to the other layer, this logical link control. Logical link control kind of takes control of the traffic control. Usually, like there should be some guy who will take control of the packets, the rate at which the packets will be sent, or kind of the communication can happen. And then you have this medium access control and physical layer. They are basically the wire over which the kind of data gets transmitted. Or in short, I can say that they can be here wireless kind of thing. So basically, I'm just trying to convey the message of the time you type something, it gets into the packets, then several kind of aspects of information gets connected, and then the packet is transmitted to the other end. And if we just now kind of try to mimic this in the sensory world, on this IoT world, we need this kind of model, because at the end your sensor senses something, you want to kind of transmit it to the other part of the world or to the other machine. Now the question here we have, can we use the same ISO model which we use in our computers? And the answer is yes, we can use it, but it's very expensive. It kind of unnecessarily adds too much of security, too much of information, extra headers, which we don't need. So to kind of save ourselves and to save our networking resources, this ZigBee comes into the picture. The protocol which I just introduced. And if you see, the ZigBee works at the corresponding layers. While we have the networking layer, you have ZigBee routing. You have the transport and application, you have some other layers. And from this 802.11, I see three layers are roughly the same which we have in the ISO model. So now the thing you have to remember here, these sensory devices, they use some kind of ZigBee protocol to kind of communicate, to kind of make the data packet and then send the data packet. And the catch here is that ZigBee is not expensive in terms of the battery, in terms of the communication. So several other benefits we have with the ZigBee. And we'll see over the time, we'll try to compare, because comparing things in the real world or in our intuitive world is always helps us to take a decision whether we should go with product A and or product B. So that was about the ZigBee, but now the question is that, is ZigBee the only protocol which exists in the world as of now? The answer is no. We have several other kind of networking protocols, several competitors. Like we have here, Thread is something called here. There is something called Aurora. There is something called Z-Wave. Bluetooth Smart is coming there. Then there was another kind of from the Sigfox, and the Wi-Fi is already there. As of now, we are very clear this Wi-Fi is very costly. We should not go with this. But then with these protocols, should we go with the ZigBee or these things? And the answer is very simple. It's not any rocket science. It's all about the kind of effort you are ready to put in, kind of differentiating the things with respect to your use case. So what do I mean by the use case? Use case is very simple. It says the application you want to build. So I'll take you through some use cases where you will be able to understand whether I should go with this protocol or that protocol. But at the end, if you are not able to differentiate, I would just suggest you just go with one. Whatever makes you laugh, whatever makes it sense. And I'm very sure that when it will fail, you'll realize, no, this is not working. Let me try another one. And I'm very sure over the time, you will kind of iteratively kind of realize what is the best for this kind of application. Okay, so that was one aspect of the way kind of you can decide which protocol or which standard to use for your application. But then we have this other kind of easy kind of diagram to understand what's going on. So I have this here. I can see that kind of it's a scatter plot, because I have two axes. On the here x-axis, it says the data rate. So I'm sorry, there are no labels, but you just assume that it goes increasing as I move towards the x-axis, move away from the x-axis, from this central point. And similarly, on the y-axis, I have several parameters, complexity, power, cost. So again, as I move upwards, these things kind of keep increasing. So if I see here this Mika 2CC1000, kind of it says that this is good if you want low data rate, a kind of 38.4 kbps. Now, to give you an idea, to just to give you an intuition of what is this KB, what is this MB, I would suggest that when you are kind of browsing your internet, when you are kind of using your browser, it's basically kilobits. You are using some bits of the data. But when it goes to kind of this video data, when you are kind of streaming, you watching YouTube video at kind of the high definition, then you need the MBs of speed. And so that was kind of an kind of spoiler here. So here, what do I see? I see that if I need low data rate and I don't want to kind of too much of complexity, power, and cost, then I might go with this thing. But in case if I have kind of requirement of 250 kilobits per second, and again, don't not too much of complexity, then this combination of 802.54 and ZigBee is the best. And now you compare this thing with these guys, like these three, at least three big brothers, you can say that. This is where the Wi-Fi is. You see that the Wi-Fi, the rate which Wi-Fi can kind of handle, or the complexity it's way higher than this kind of Zigbee. So again, it turns out that in the IoT world, we don't want this much of complexity, no power, no cost, and low data rate. Then again, this helps us to decide, yes, we should go with the Zigbee kind of thing. And this is another protocol, sorry, another diagram to help you to kind of decide what to do. Now, I'll give you a simple scenario because this is what you can understand. Because suppose you are in the Baramulla or you are in the Srinagar and you just want to kind of sense something. For example, you want to build a system where you can sense the air quality of the Srinagar city or air quality of the Baramulla. So the question is, which protocol should I use for my IoT setup? Is it like I should go with the Wi-Fi or I should go with the cellular or I should go with the LoRa? And here, just to give you an idea what this range on my x-axis is, so you can assume this Wi-Fi maybe 20 meters or 25 meters. Let's go with this 25 meters. And this cellular, I am here, like it starts from here. So I can maybe I roughly go for 3 kilometers, 3 to 4 kilometers. But then LoRa kind of, I can see the range which I can assume here is maybe 20, 25 kilometers or 30 kilometers. And on my y-axis, it again shows me the bandwidth kind of, whether it's a low and high. Now, you just assume that you want to monitor the air quality of the Baramulla city using the different sensors. Which protocol should you use? So if you use the Wi-Fi, the range won't be too much because it is just in terms of meters, and the bandwidth will be high. So by high bandwidth, we mean that it will consume more power, more battery. And if we just want to monitor this air quality, while we just want to see what's the carbon dioxide, what is the oxygen, nitrogen dioxide, all these parameters, we don't need this kind of Wi-Fi for this kind of the data. Similar goes to this cellular. Now the cellular, the problem is again, it turns out that it's kind of bandwidth hungry and the kind of range is not that much because my simple kind of assumption or the requirement is I just want to transmit from one end of the Baramulla city to the another Baramulla to the other side of the Baramulla. Then in that case, this LoRa makes the sense. Now you might argue that cellular I can install several towers, but then also look at the bandwidth. The kind of bandwidth is directly proportional to your battery. We don't have that battery. So again, then it turns out this LoRa is a kind of complete winner. And all of these protocols are publicly available. LoRa is publicly available. You just need to download, install it on your sensory nodes, and the system will be up and you can communicate. So it's very simple. So now here we'll have a kind of fair comparison between these protocols to just get an idea why we are after the Zigbee instead of this Wi-Fi or the Bluetooth. So the first row, if I go through this is the application folks, it says that this Zigbee is usually kind of good for this monitoring and control. And that's our whole entire purpose. That's why we want to monitor different things or we want to control different things in our world. And if that's the thing, then Zigbee is the best. Now, why this? Are there any numbers? Is there any support? It turns out that if we have a battery with the Zigbee, the battery can stand for at least 1,000 days. At most 1,000 days. While as if we use the same battery for the Bluetooth, it will just kind of stand there for at max 7 days. Now, here you can again kind of try to have an intuitive thinking. It's monitoring and control. By monitoring and control is we want to deploy our setup once and then maybe we want to go for a sleep because we don't want to kind of take away our setup each and every day. So again, in that case, it turns out that we don't want to replace the battery each and every day, and this Zigbee kind of makes sense. Then the other thing which I wanted to highlight is, yes, the range. It says that the range between two nodes, I'm not talking about the entire network, just the communication distance between two sensory nodes. It says that you can go up to 75 meters, the distance which can be between two nodes. While as here in this Bluetooth, it's just 10 meters. Wi-Fi and GPRS. Although the range is higher, but then you have to keep in mind their battery requirements. Battery requirement is way high and we don't want to kind of change battery in the monitoring and control setup. Similarly, I'll skip this slide. It's basically, it shows the comparison between the Zigbee and its competitors. It's basically different companies kind of coming with different protocols, but at large, they are at the same place. It's just about the complexity of our IoT setup when we want to deploy it. Do we want to go with a simpler setup, or do we want to go with a complex setup? And this is, I just took it from one of the research papers, and it's a very simple setup. They have done it. And I encourage you to kind of do it because you can do it. It's not that difficult. So what they have done, they have some kind of central system which they have labeled as internet. We'll go here and we'll try to understand what this internet is. And to this internet, it seems that they have they are connected to this Wi-Fi which is deployed in a home, and then they have some board. It's a Raspberry board, and then they have this basically current sensor, which is kind of sending to this node, and then to the router, and then to the internet. And then here it says intra-vehicular wireless sensor network. So basically, this box is in a car. So again, here we have this. This is a mobile phone which is inside a car, and then it has different nodes. And then it's a user who is having the mobile phone, and then this is a Firebase. So what's a Firebase? Firebase is a here cloud on which entire data is stored. Basically, the data which is coming from this upper block, it also goes to the Firebase, and the data which is coming from the lower block is also going to the Firebase cloud. So basically, in nutshell, in real time with your mobile phone, you are able to see what's the energy consumption of this home, or what's the energy availability in this home, and what's the energy availability of my car. Now, what's the big thing here? So basically, the research aspect, research angle, they came up. They said, suppose we have a car and you are going to Baramulla, and you want to kind of charge your car. Now, the question is, which home you should approach. And your idea is always that you will approach to that home only, which has sufficient energy, which has sufficient kind of energy kind of available. So they said that we'll come up with this IoT setup which connects all the homes and my car, and in the real time, I would be able to see which home has kind of what kind of energy available, and accordingly, I'll reach out to that home. So if there are any questions, feel free to interrupt. I totally sorry. I forgot to mention this thing. So this is all good. So until now, we built an understanding that we can. I'll quickly go through, give it a flash so that you'll see that where we are. So we are here. So this is a car, and in this car I have as kind of installed this board, and this board is connected to these different modules through the wireless connection. And the wireless connection, I will assume that we'll use the Zigbee. So given now we are able to connect different modules via Zigbee on a board. So until now we are good. We don't have any problem. Now but the thing is, it is still about one car. So with respect to one car, you are good to use. You can use the Zigbee and get the things done. But then the question comes up, I think this is the question. How can a car manufacturer monitor an vehicle scalably and reliably? So it's kind of a Tata. Tata is saying that I'm in the Kolkata, and from the Kolkata, whatever cars I have, kind of EV cars I have kind of supplied to India, I want to monitor all N cars in the real time, because the case is very simple. If any car goes down due to one or the other reason, the first problem is that it's a kind of danger to the human life, and the other car, it's other thing is it's a reputation of the Tata. So they have to make sure that somehow they want to monitor N cars all the time in the real time. So how can we use Internet of the Things to monitor all these cars in the real time? So this is a question. You just think about this for a second, and then I'll go through it. So in simpler words, basically this is our problem. We have three parties here. Let me kind of generalize it. So on one side, I have some sensors, actuators, edge gateways, embedded controls. You just forget about these things. Just remember the sensor. And where is the sensor? This is in a car. So we have N cars. So there are these sensors are in n different cars. So each of the car has a board which is connected to the sensor. And it turns out that these sensors are connected to this party. And what is this party? Let's assume that this is internet, some kind of big machine, and you are connected, I will say some Zigbee or some kind of internet way through which you are kind of connected here. And then from this party, you are kind of connected to the other party, which is the mobile phone here or some kind of display, where you just want to visualize and respond. Now let's take the Tata's case of how the Tata will come into the picture. So here are these N sensors are deployed in N cars, and the data from each of the car is going to the cloud, going to the internet somehow. So there is some big machine here in the cloud, maybe it's in USA or some other country, because it's also connected to the internet. And then this machine, which is storing the data in the real time, it's kind of connected to this mobile phone, and these mobile phone displays, they are at the different offices of the Tata. Now, what's our issue? Our issue is that how can we connect in the real time, like the offices can connect to this cloud, and then cloud connects to each of these sensors in different things. Now, in other words, on this side, we just want to sense and control. We just want to sense what's the state of this car. And in worst case, in kind of in extreme case, if we see that car is not doing kind of good, or it's not going as per the kind of safety protocols, then we won't control it. Maybe we want to send some message, we want to kind of lock the car and kind of get it stuck there. And other thing we see here, the Tata offices, what they want, they just want to get the alerts whenever something kind of happens in its parameters, maybe the current voltage or the temperature, it want to get an alert, and it want to visualize, and accordingly it want to respond. So I'm sorry, could you please repeat your question? Okay, sorry. So this is the kind of the scenario we are kind of planning to go through. And now you'll see that how Internet of Things are kind of, what is the way to uh, kind of monitor n number of cars, and then we have this kind of setup, sense control and data alert. So is there any protocol which can help us in this way? So the kind of computing paradigm we will be using in this is called cloud computing. I'm very sure many of you are kind of aware of this cloud computing, but I'll still give it a try, give it my best to kind of explain cloud computing. So what cloud computing says, cloud computing, computing paradigm, it says that to these kind of owners, to these cars, it says that, hey, you just install a sensor and you kind of remain connected with the internet. And then you push the data to somewhere here. And what is this somewhere here? Basically, these are machines, which big computers, which are maybe at the different parts in India or abroad. And then these machines are internally connected to the machines of the Tata offices. So if you see that Tata owns just the mobile phones, just laptops, just small things. They are not putting money on these machines because they don't want to have their private machines. Rather, they go to this third party kind of thing. Maybe it's Amazon, or it may be the Google. It says that, hey, Google, or hey, Amazon, I just need computing. Can you do the computing for me? And I will pay. And again, this owner here, they are not paying. So if we see in nutshell, neither the car owner, he does not need to install the machine or kind of the purchase machine, nor the Tata, they don't need to purchase the machine. They simply take the service of this big guy, maybe the Amazon or the Google. So this kind of paradigm, this kind of computing paradigm, we call cloud computing, where the machines, the big machines, are not owned by the end user. So what are the benefits of the cloud computing? Several benefits. The first one is reliable, because you need to purchase a service, and then the cloud provider, maybe the Amazon or the Google, they will make sure that the system is always up, and it's flexible. Maybe initially you just say that, hey, I need two machines, but over the time you can add your computing power, or kind of the networking power, or the kind of the storage power. So again, it's kind of a win-win situation. So that's what happens today in the startups. So suppose tomorrow you come up with a startup idea saying that, hey, I need to set up a company, and definitely you need this computing power. But then the question is that, do you want to purchase your computing power, or you just want to give it a try with the cloud. Most of the companies go with the cloud because they don't know whether the company will run or not, but at least they are very sure that the kind of money they are kind of putting on the cloud, it's just for the service they will be using. Maybe after 2 months or after 1 year, they kind of have to have their own computing power, and then they can abandon at that time cloud computing. But definitely, it's a way to go initially, and it's financial, that's what I said, and it's up to date, so you don't need to kind of update the machines. It all happens at the back end. You just kind of want to make sure that whatever things you need, that gets done, so you don't need to install any updates over the time. Okay, that's good. So now at least we figured it out that we need to have cloud computing in this IoT setup. But still, one question remains: how do we transfer the data from these devices to the cloud? Because again, I'll give you simple example again here. So here, just suppose that this is one machine, and kind of this is another machine. In simpler words, I'll kind of let me kind of show you. Okay, it's not allowing me to kind of move on that side. So basically, the kind of example I wanted to show you is, suppose whenever you type or you open the browser, you write www.google.com, and then after some time you get a page. So what is the communication protocol that's being used under the hood? So is there any communication protocol which is being used to send the request and then get the data? So it turns out that yes, there is a protocol which we call HTTP or HTTPS, which we usually, maybe you have observed it when you type the address that comes before the address. HTTP, that's a hypertext transfer protocol. So can we use HTTP? Because the need is same. We want to transfer the data from one device to the other device. Here, one device is our the small board, small sensor, and the other device we have the cloud. So maybe in the coming slides, I will show you that HTTP is not a good choice. Rather, we go with other kind of transfer protocol, which we called as MQTT. That's a message queuing telemetry transport. It's kind of, you can say that it's an alternative for HTTPS for low bandwidth machines. Bandwidth machines, low bandwidth means basically we don't want to transfer too much of the data. And we know that our IoT devices or IoT machines, they simply want to send some heartbeat data, maybe ones and zeros or small packets saying that I am on or off, or my health is good or bad, or now the temperature is right now this, and after this time it's changing. So the data hardly changes. Or even if it changes, it changes by a small margin. So we know that these kind of communication systems, we call them as low bandwidth kind of communication systems. So for these low communication bandwidth systems, we use this MQTT protocol. And these are few of the characteristics of these MQTT protocol, which kind of encourage it being used for these low communication protocols. And now, why this is kind of being kind of, I would say, supported for these devices, because it's very simpler, or the kind of the implementation is publicly available. Tomorrow, if you want to use this MQTT in your setup, you can download the specification and you can encode it and kind of use it in your system. But still, we would like to have a kind of big picture of this MQTT. How does MQTT works, or what is the push-pull mechanism in this MQTT? So what do we have in the MQTT? Again, I'll take you back because this will make it easy to understand what do we want. So you just, as you, I kind of come here again, I have three parties again. So I have one sensor here. I have some kind of big, I'll say that internet here, or big machine here. And then I have this visual interface here. So I see here three parties: sensor, kind of some intermediary, and then this kind of the consumer, the day end consumer, which uses the interface to see the data. So now the same thing is the kind of the backbone of the MQTT. What MQTT says, it says that I have three parties. One is the publisher, which kind of keeps publishing the data. The another one, I have the broker. It's kind of the, you can say it's a middleman, which kind of takes the message from the publisher, and then it kind of transmits to the subscribers. So it's kind of we keep subscribing to many things, and the whole idea with the subscription basis is whenever a kind of new thing comes up, when a new update comes up, we with subscriptions we get that data automatically. The same thing is in the IoT. It uses the MQTT protocol, and MQTT makes sure that there is some publisher, there is some subscriber, and then there is some broker. Again, we'll go with some other example of MQTT with respect to the IoT. So suppose you have installed several sensors in your home to make your home smart. So what do you do? So in your house, you go to your one of the room is office, and in your office there is a lamp, and on this lamp you have installed a sensor. Maybe the sensor is either on or off. So we can say that this lamp is a smart lamp because you can control it from the mobile application. Similarly, you go to your house, then in the kitchen, and in the kitchen there is a door. You install some sensor on your door, and what that sensor can be, it can be maybe turn on or off your door, or it can be just to sense how many people are inside the room. There are multiple states of a door. And then we have another sensor which is we'll start with your house and then one of the rooms, and the sensor is connected to the window. Again, maybe the sensor is just monitoring the kind of the air quality of your room, or it can be used to turn the window on or off. So in nutshell, I have three publishers which can publish their state to the central broker. And what is the central broker? You can just assume that in your home you have some Wi-Fi box, kind of some box, or some kind of small physical box to which these sensors kind of keep talking. They keep sending their state. And then on the other side, these devices, what are these devices? I can just assume that these are mobile phones, or these are some interfaces. Maybe this device is in my office, this device is in maybe some other office, or this device is in my room, sorry, in my pocket. And now what happens, whenever the state of this lamp changes, the broker knows that this device, this mobile phone has subscribed for this data. So whenever something happens here, it immediately pushes the state here. So here I have three end devices, three user devices. It turns out that for each of the devices, I keep pushing the data whenever I see a change in the data. So the same thing is entirely with the MQTT. Now, if you see how MQTT helps here, it's very simple. Suppose out of 1,000 cars, one of the car sees that there is some problematic value, or there is some unknown value, sensor value. So it quickly senses, it sends that to the cloud, and cloud kind of sees that the value is kind of somewhat coming bad, or it's kind of anomalous value. It sends an alert to the Tata group. So, and now you see that it's kind of a real time. You don't need to kind of, what should I say, this refresh. No, there is no need of refreshing. You just, as soon as the change happens on one side, it immediately gets pushed to the subscribers. So that's the power of the cloud computing, or that's the power of this MQTT. Now, if you see that although the Tata has hundreds or lakhs of the cars, they just use this MQTT in all of the cars, and these MQTT make sure that the data kind of reliably gets pushed to the cloud, and they get alerts in the real time. Now, you see that how easy it is kind of going with these protocols, this MQTT protocol. Okay, so definitely when you purchase a service, suppose you want to purchase an air ticket, or you want to purchase any kind of thing, you get an option which kind of service you want. Do you want kind of low service, medium service, or high service? And the difference usually remains in terms of the facilities they provide. So in terms of networking here, we have something called as a quality of service. It's a kind of a technical term, but as the name says, it says that what kind of service you want. So here we have one side on a client, and on the other side we have a broker. Suppose if you say that, hey, I want quality of service level 0, what it says basically whenever client has some data, it will just push the data and that's it. It does not care, it does not verify whether the data was received by the broker or not, because that's what lowest quality of service. Your job is just to push the data. But in case if you want to go with the quality of service 1, you need to make sure that whenever the broker kind of gets the data, it gives you some acknowledgement. That means if you go with the quality of service one or you purchase the quality of service one, this client has to kind of guarantee that it get acknowledgement. In other words, it means that if it won't get acknowledgement within some time, it has to publish this packet again. It needs to send the packet again and again until it gets the acknowledgement. While as with this lowest quality of service, you did not care. You just push the data. Now you see the difference. The kind of the packets this can has to send are way higher than this quality of the service. But it turns out that there is one more level of the quality of service. That's the quality of service two. Quality of service too kind of, it gives you more kind of I would say freedom or kind of more kinds of reliability. So what it says that okay, client will send the data to the broker, and oftentimes we do this in the real time. I'll give you a real world situation. So suppose you have a friend, you tell him that hey, please go to the Baramulla, but after 2 seconds, you get an idea. No, I don't need to send him to the Baramulla. He should go to the Srinagar. So you quickly make a call again saying that, no, please don't go to the Baramulla, go to the Srinagar. So this thing happens in the networking as well. So now we can have an example here. So suppose this is a temperature sensor and this is some broker. So now it might happen that there are small fluctuations in the temperature here on the client side. Now, does it mean for each fluctuation, this broker needs to take an action, or the broker should take an action only when something substantial happens? So that substantial thing, that decision-making thing is ensured in the quality of service too. So it kind of, when this client sends this publication release, and it gets this publication complete, then only this kind of releases the connection. And if you see, at least kind of in a naive manner, the number of packets to send a symbol or one packet are kind of way here more than compared to the QoS1 or QoS0. I don't want to go into the details, but I just want to give an idea that you have a kind of a freedom to decide how many packets you want to kind of send, what kind of reliability you want, because see, sometimes there are applications which are very time critical. Maybe some applications you are not time critical. You just want to get a state of the thing. So depending upon the criticality of the application, you decide which quality of service I should go with. Okay, so coming back, I said that, hey, instead of the MQTT, we can use the HTTP or HTTPS. But it turns the cost associated with this HTTPS. Suppose if we are just receiving message, it says that a node using HTTPS can receive just 1700 messages in 1 hour. But if you are using this MQTT protocol, you can receive 160,000 messages in 1 hour. Now, if you just compare these things, the margin is the difference way higher. So definitely in monitoring and control, we just want to send small message. It's not, we don't want to send big messages. So in that case, definitely we would like to go with this small message. And it turns out that you have a kind of a bigger margin here, or you can have more number of messages with the MQTT. Similarly, there are several other ways, like the number of messages which can be sent in the MQTT is 21,000, but here it's just approximately 2,000. So it altogether kind of boils down that this MQTT is kind of the most appropriate protocol for the publish and subscribe thing in the IoT domain. Okay, so I'm just kind of concluding. I have, I think, 2 or 3 slides, so please bear with me. So now, altogether, we have at least, I'll revise few of the things. So I started with one board in a car, one microcontroller in a car. Then I said that if I have different components which I kind of want to connect, can we connect them wirelessly? We said that yes, we can connect them. We can have the Zigbee kind of thing, because Zigbee is not energy consuming. So locally, we can establish communication with the Zigbee. But then we had other question, how can a Tata kind of monitor n number of cars at the same time? We turned out that to kind of monitor all those cars in the real time without any delay, there is something called as MQTT. So as of now, we know two protocols, MQTT is there, Zigbee is there, which can be used. And now the question here is that, can we use MQTT here? Now, if I have to kind of help you, So basically, I'm saying that, hey, I have a car, and in this car, I have different sensors. I have a video camera, I have a radars, I have position sensors, GPS, LiDAR, radar. Can I use MQTT to send this data? Just take a second. So the answer here is that this video data, you already know that video data, it's kind of bandwidth intensive. We cannot use MQTT for this video data. For rest of the things where you have just the values, where you have kind of time snapped values, MQTT makes sense. But for the video data, you cannot use the MQTT. You have to use some other kind of protocol, maybe the HTTPS, to send this data. Okay, now let's go through the demo quickly to see whether we can do some of the things. Basically, what do I want to show you? Let me kind of. So I have here, you just see that in my hand, I have this small board and I have a small sensor. And this is what is shown on the slide. So I'm saying that, hey, I have this ESP32 microcontroller. Then I have this temperature and humidity sensor, which is on. And this other picture says that basically this entire setup is connected with my laptop right now. I just took these pictures 10 minutes, sorry, before the talk. So I just wanted to show you that how simple is this, and you can do at your home. Because if you are clear with one example, you can just apply it on n number of use cases. And I can just show you that these things are easily available on the Amazon and they don't cost too much. So the thing which we'll be doing here, uh, we just want to monitor the temperature and humidity in the real time. And we just want to display it somehow on our mobile phone. I think that's our goal, and it's very kind of likely a goal. So I taught you several things. Let's see that whether we can apply these things in the real world. So I think the problem is very clear. We want to monitor temperature and humidity in real time in the mobile application or on some kind of laptop and desktop. So for this, what I'll be doing, I have just written this small programming script. But for your thing, for your I have just broken it down into small chunks. So the first chunk I see that initialization. So programmatically, I'm just initializing something. It's kind of basically you are about to go for a travel or kind of final vacation. You kind of initialize something. You start kind of preparing several things. So I need to write some code. So I need to make sure that the ground is there. So I did some initialization in the programming. Then the other thing I make sure that this tiny board, it should get an internet connection. And the question here, maybe you guys have a question, how it will get internet. So I have my mobile phone here. I have created a hotspot. So I'll make sure that it gets connected to the hotspot. So I mentioned here the settings of my hotspot. What is the this SSID? What's the password? So again, this is a stable piece of code. I don't need to kind of tinker here and there. Then the third thing here is that I'm trying to connect to the MQTT broker. And what is this MQTT broker? To just give you an idea back, let me take you to this picture. So right now I am here. I want to connect to the broker. So the broker is here. What should I do to connect to the broker? It turns out that just 2 or 3 lines of the code. You just see 2 lines of the code. I'm saying that, hey, please connect me to the Blink. And what is Blink? Give me a second. I'll see that if I can share you this. So this is my browser. If I type here Blink, so I'm already logged in. It's kind of a cloud service provided by this Blink, and they run the MQTT protocol in the background. So I would like to see my things here in the Blink, and the application I have already created. I have created some widgets. Temperature is 24, humidity is 56. But just see that I'm not sure that whether I'm pushing data right now. But as of now, I just assume that these are the default values. And now Now I'll show you my code, how I'm kind of sending the data. Okay, I hope you can see my screen. So what I'll do, I'll just use one application for I'm using uh, which I call Thony, but you can use some other application and see what I'm doing. The same piece of code which I just showed you is here. I'm just initializing few things and I'm connecting, trying to connect to the internet, then to the Blink server. And then I'm just regarding the board, what I'm trying to measure, I have written that thing here. And every 3 seconds, I'm trying to send the data. Maybe I can make it 1 second. So every 1 second, I will sense what's the data. So this is my program. Now let me run it. I hope that it should run. I hope that you are able to see my screen. So it shows successfully connected to the Blink server. Now let's go on the Blink server and see what's going on there. Okay, so this is already, it shows that you are online right now. I am connected to this. Now I'll blow my I'll put this temperature sensor in my mouth to see whether I can increase that temperature. So you can see, I hope that you are able to see in the real time, I was basically able to see the temperature values, which are kind of this sensor node is able to measure. Now, it's very simple. The kind of point I'm trying to make is now suppose that this sensor, this small chip is in our home or in our cars, and we have an internet connection. And this board does not need kind of any sophisticated battery. It simply needs two that AA batteries or 3-volt batteries, and it does its job. The only thing you have to make sure that you push the code once on this board, and then whenever you start, you say start, it kind of starts. So just give me, I think I'm done with all these things. I'll fix this. I'm back to slides. This was all about, like I was showing that how this is possible. And if you want to take it to the next level, this is kind of a small project which you can do at home. So the code is, everything is given here. He's kind of explaining all the steps. Now, the only thing which you need to purchase from the market, if you want to give it a try, because I think this is the best time, winter is the best time in Kashmir to kind of try to tinker with these things and to learn something new. You just need to purchase this board, which is called ESP32. It's available on the Amazon. It costs 380 rupees. And this temperature and humidity sensor, which we call this as DHT11, it costs 30 rupees or 25 rupees. So in 500 rupees, and then you need this wire. You already have this wire because this is the wire which we use to kind of charge our mobile phone. And you need just laptop. And once you have all these things, you need to just go on the Blink. Blink is again publicly available. It's open source. You don't need to pay a penny. You just kind of play with this thing and you can do the wonders. At least you can learn IoT kind of during this month. And if you are kind of bit confident with one application, you can just explore kind of just extend to n number of use cases. Right now, I just showed you how to use the temperature and humidity. But then if you want to monitor maybe the heart rate of a person or some other parameter, it's just you need to change the sensor and just make a small Google query saying that, hey, what is the specific sensor that I can integrate with the ESP32, and I just want to see the things in the real time. And you can get the answers on the Google, and that's how it works. So these are few of the references which I just kind of want to share the kind of stuff I have taken from these papers. And I'm ready to kind of take any questions if you have. So before kind of closing, I just want to make sure that you gain something from this presentation. It was not entirely research based. It was somehow kind of the motive was that you gain something. Maybe you gain, you learn, you get to know that there is something called as MQTT, which is a replacement of HTTP, or there is some called as Zigbee, which is a replacement of the Wi-Fi. And then there was this thing. I show you something that there is some called a Blink. You can play with the Blink, and this is all at free cost. So being at students, I kind of highly encourage you to get this thing and play with the experiments. So please go with the questions if you have any questions.
If anybody having question, please raise hand so that, or you can ask directly.
Yeah, in case because I'm from the same background and I should not criticize, but this is how we have been programmed in Kashmir. We have the question because the kind of talent we have in the Kashmir is kind of it's fabulous. But the thing is, we are somehow kind of shy. We don't ask the questions, but at the day end, it's kind of our loss. So I'm very sure that all of you have the questions. In case you have a question, please send it to me via my email, and I would be happy to kind of help or kind of to answer your queries. But my bigger suggestion or the thing is, I would always encourage you to ask the questions, and it does not matter how the question is taken by the kind of the person on the other side. You just need to ask, or you just need to speak.
Harun, I don't think there will be any question, but I do have one
Sure, please go ahead.
because I can't stop myself to for non having no questions. So the things are that we have in foreign countries we have Tesla, we have other companies which are driverless cars, we can say. But what about the scenario of India? Like we have a messy traffic. How we can see in being the motto of a developed country by 2047. How you are seeing this digital initiative with respect to automobile initiatives or other things that it can be incorporated here in India. What are the challenges that we have to face, or we are lacking here?
Yeah, so definitely this is a kind of very ambitious question or kind of the ambitious thing which we are kind of hoping for, but definitely there is a hope. So the bigger thing, if you see, like you can just Google it and try to understand what's the difference between developed countries and the developing countries. So the bigger thing which kind of somehow erupts up at the top is the protocols or the rules. So the developed countries, like you take the example of the Tesla, so I can challenge them if they can kind of run the driverless Tesla car in Delhi or kind of in Indian city. So these cars, these sophisticated cars, they are still kind of at the evolving stage, and where they need to make sure that the system is deterministic. By deterministic, we mean the system kind of or the environment goes with the set of the rules. If we see in India, as of now, it's very difficult to go with a set of rules. Even if you kind of drive a car, you will find out that even if the other person driving the car knows the driving rules, he has a driving license, but the way he drives on the core kind of the road is very reckless. The same thing goes with the automated systems. Even if the drivers are not able to drive the cars safely on the roads, how these kind of these, I would say, these machines or automated systems can handle that challenge, that's a big thing. So now my simplistic answer to this is until and unless we can show somehow deterministic behavior on the roads, uh, it's way unlikely to have these cars in India. But yes, there is a hope if the deterministic behavior kind of emerges on the roads, this can be kind of done.
My second question is regarding the security aspects of these cars. The automated vehicles without drivers or any other automated, like you have shown us a demo of sensors installed in some rooms where we can monitor different kind of the thing. Is there any kind of the security mechanism involved, or Are we lacking that particular thing in that? Or there is any kind of the direction that we need to take up?
Yeah, so before answering this question, I will kind of for a time take a pause and try to understand what kind of security we have the wired systems or the wireless systems, basically the established, the power intensive source like the laptops, these kind of machines. If we see over the time or over every day and each and every day, there is some kind of hack. Someone's password got stolen, somebody money got stolen. So one thing is very clear, even our sophisticated systems are not security proof, where there is no kind of dearth of resources, where there is a battery, where there is a bandwidth. So there is a kind of security loophole in these established systems. Now, if we try to mimic the same problem or try to apply the same problem on these sensory devices, then we are not near to anything. It's just we are trying to make sure that these sensory systems work reliably, but the hope is still there. Over the time, we'll see that these sensory systems will work reliably, and then the security aspect can be kind of taken into consideration. As of now, there is no hope.
We have one question in the chat. Some Lone Shahid has a question. Can we use this software to measure the time by which our EV cars will get fully charged?
Yes, it shows you the time. So the only catch is that you need to have some kind of this board or some other board to have a kind of establish to kind of get integrated with the BMS, that's the battery management system. And then you write a small piece of the code and it will show you all the things. What is the current state of the battery? How much more time it will take to kind of get 100% charge? I'm very sure that the existing data in your mobile application, then you can get it done.
I think we have one more question by Dr. Sayed Ejaz Farid.
Yes.
Sir, please.
Am I audible, sir?
Yes, sir.
Uh, Welcome to this session on my behalf. Though it's their job who are, conducting the proceedings. I am not well versed with technology, but recently I found in the market I had gone to buy a lamp for we usually use LED lamp in our rooms for lighting purposes, and I found it that it's not the material that was being used previously. It was sort of a very soft type of a rubber or plastic type of a thing. So the question I asked the seller, I told him, is it safe, or maybe it creates some problems or some circuit short, or maybe it expands due to some, though it's cool light, So I would like to pass this question to you, sir.
So, to be honest, uh, I have no idea about this system, but I'll simply it's a kind of a guess. My simple guess is that definitely it would be some bigger company. Wipro has started doing some things on this side. They have been working on this IoT smart bulbs from last 2 years, and given they have gone to the production side, to the kind of the consumer side, they might have taken those aspects into the picture. But since I have not used the system or I have not seen this bulb, it won't be a kind of would be a kind of a justice with that bulb, I think.
Well, it's a registered company and it's in the market. Anyways, let's discuss it on some other ground. And
Sure.
my another observation and the thing that I want to discuss with you is one of the great problems and menaces, in particularly in the urban environment, is that we are suffering from noise pollution, right?
Right.
So, in your field or whatever you have studied, what do you suggest, or what are the measures that are being taken to reduce those decibel levels in the modern world when we have artificial intelligence and the sort?
So basically, if I try to break your question, in nutshell, so this IoT, it's kind of basically up two parts. One is the sensing part, where the monitoring part, and the second part is the control part, where you kind of try to control the things. And if you see over the time, the applications of the IoT, I will break them into 90% and 10%. 90% of the times, it's just we want to monitor what is going on with the system. And it's just that 10% of the time you try to control the system, or kind of you try to tune the system. And now coming to your specific question regarding the noise pollution. So definitely, again, we have two aspects here, monitoring aspect and the control aspect. Monitoring aspect allows you to kind of measure it at a finer level, at a granular level to see what kind of noise is generated at different levels. But going to the control part, it's at the day end, it's a human problem. The sensory system will give an alert, hey, saying that you are using the voice is kind of, or the noise floor is too much. You need to reduce the noise. But at the end, it's you, it's the user who has to take a conscious decision whether I want to reduce it or not. Because I'll give you a simple example. All of us have the kids in our homes, so they try to kind of increase the volume, and the mobile phone gives the warning that it's too loudy. But still, the kids kind of they don't care. They just listen to that thing. The same thing is in the IoT. IoT gives you the provision, but at the end, it's a human problem. It's up to us whether we want to kind of reduce the noise floor or not. I'm sorry, I don't have any concrete answers to your questions, but this
No
is how
issues.
I kind of think.
No issues. No issues. Deliberations and debates. With the good deliberations and debates, there's an exchange of knowledge. This is knowledge sharing. You have
Sure.
made your best efforts. Thank you very much for being with us.
Thank you. Thank you.
I don't think we have any more questions. I request Dr. Mutahar to take one.
Thank you very much, Dr. Bilal. Tariq sir, are you there? Tariq sir? Okay. So thank you very much.
Uday sir, Principal Saab is here.
Oh, Principal Saab is here. Sure.
Ah.
Over to you, sir.
Thank you very much. I was not able to hear everything about it, but the way he was talking to it means the technology is in the right direction. I hope you are getting benefited out of it. A very simple question. The present scenario of India is that we are managing the existing machinery system. Is there for the youth possibility of innovation, creativity, and research simultaneously?
Yes, yeah. So definitely, right now the bigger challenge in India, it's not about the innovation, it's about the understanding. Our generation is not ready to kind of understand the technology at hand. So suppose, for example, I just explained this concept, the way I was kind of explaining it. My idea was to take it to the students so that they go home within 1 month, they try to kind of play with it and understand it. But I can challenge like the 50 participants we had here, the students especially, if they are ready to take this challenge and understand. Once they understand, then their next step usually is the innovation, the tinkering part, where you try to see, okay, now I understand the system. Now, how can I take it to the next level? So the challenge we are facing in most of the pockets of India is that students are not willing to take it to that level. It's kind of mostly the job driven scenario. While they want to get a job, they want to get benefited, that's it. But definitely, our youth has a potential. As I'm from the Kashmir, we have seen several use cases. Some specific students, they take it to the next level and they try to kind of improve. Like, for example, there were several questions regarding the noise pollution. This is a real problem. In Delhi, a few days back, we had this air pollution. This is again a realistic problem. And now the question is that is our youth ready to kind of innovate and try to bring smart solutions so that these problems can be handled? I think at the end, it's again the motivation are the kind of the thing whether you want to get it done or not.
Thank you, sir.
Thank you.
So I trust you all found Harun's lecture as enlightening, as thought-provoking as I did. And as the coordinator of internal quality assurance cell of the college, I am honored to extend our deepest gratitude to Dr. Haroon for sharing his expertise with us. So as we conclude this session on the integration of IoT in electric vehicles, on a lighter note, I can't help but ponder that some of our participants may be scared of the future of artificial intelligence, AI, and you know, these robotics and all these things, a future where somehow our vehicles might become smarter than us. And I assure you, I'm not questioning your intelligence. I mean, it's not like our cars will somehow start judging our music choices. Like, imagine my car is saying, I'm sorry, Mutahar, I can't play the same ghazal that you have been listening 17th time again to you. So that's the kind of basically future that Dr. Haroon is preparing us for. So let's embrace this future with a smile, because if we got laugh about the impending future of AI, we might just find ourselves on the wrong side of the algorithm. So on a serious note, Dr. Haroon, your insightful exploration on the integration of IoT in the realm of electric vehicles has been both informative and forward-thinking. I'm sure your ability to unravel these complex concepts and present them with clarity has undoubtedly left a lasting impact on our participants. On behalf of the IQAC and all the participants, I express our sincerest appreciation for your time and expertise. Once again, Dr. Haroon Rashid Loan, I thank you for this inspiring session. We're also thankful to the Department of Higher Education, especially the Principal Secretary of Higher Education, Shri Alok Kumar sir, for his patronage and guidance in the organization of this webinar series. We're also thankful to the Special Secretary, Higher Education Department and Director Colleges for their continued support. And we're also thankful to the Nodal Principal, Kashmir Division Colleges, Professor Ajaz Bashir, for his kind encouragement. Every event or program that we endeavor to organize would not materialize without the guidance and support of our head of institution, our worthy principal. We're extremely grateful to our worthy principal, Professor Mohammad Farooq Rathar, for taking his personal interest in mentoring and directing this webinar series. Thank you, sir, for your encouragement and guidance. I also extend our sincerest thanks to the staff secretary of our college, Professor Chalku, for his guidance, encouragement, and support. I must also place on record my sincerest appreciation to all the members of the advisory committee, Professor Shugufta Nasreen, Dr. Humaira Qadri, Dean Research, and Dr. Abduruf Bhatt, our Dean Academic Affairs, for pinpointing the minor details which made this webinar series a success. We're also thankful to the head postgraduate Department of Computer Science, Dr. Nisar Ahmed Wani, and Mr. Nisar Ahmed Kangu, and all the other faculty members of the department for their enthusiasm and support. We're also grateful for all the participants of this webinar series for your continued participation in this webinar series. Thank you, and we hope to see you in more webinars in this series. Over to you, Bilal sir.
Thank you everyone for participation, and thank you Harun sir for sparing some time with us. Thank you all.
I
Thank
request
you.
the participants to open their cameras for
For
a
a
minute.
group photo.
Yes. Thank you. Yes. I can see Professor Altaf sitting in the IQC hall of Baramulla College. Altaf sir, welcome back.
Thank you, sir. Gigi, I'm here.
Thank you. So many familiar faces. Thank you, everyone. We're extremely grateful for your participation in this webinar series. We'll be closing the session now. Thank you very much, everyone. Thank you.
Thank you, sir. Thank you so much. Thank you.